In this lecture, we will be talking about the AWS load balancers, and before of that, I would request you from all of you guys that if you are actually having some of the noises in the audio, might try to somewhat ignore them. I would try my best to actually reduce the noise. So let's get started with the load balancers. So we have four kinds of load managed load balancers on AWS. You have the Elastic Load Balancer, which is like the old generation, which supports HTTP, HTTPS, and TCP, SSL. Like the SSL is the which is like the secure version of the TCP. And then you have the ELB Application Load Balancer, which is version 2, new generation. It supports HTTP, HTTPS, and with the WebSocket. And you have then the Network Load Balancer, and also newer generation newer generation of network load balancer supports TCP, TLS. Like the TLS is going to be the secure TCP, and as well as it supports the UDP. And then you have the gateway load balancer from 2020 onwards have been released. So gateway load balancer GWLB, which operates at lower level, so layer 3, which is a network level, the IP protocol. So overall, it's going to be recommended to use the newer kind of generation load balancer versus the classic load balancer, as they have more features, and they are going to be supported by AWS over time in the future also. So we are going to do a deep dive on all of this classic application and network and gateway load balancer. And finally, some load balancer can be set up internally as private or externally as even the public Elastic load balancers. So we will be moving on with the first one is the classic load balancer. So here you have the health checks on it. They can be at the layer 7 with HTTP, or at the layer 4 with TCP based on SSL. It supports only one SSL certificate, which is the problem, which is a problem. But the SSL certificate can have many subject alternative names. So SAN, subject alternative name. But in that case, if you want to add or remove SAN, then you need to update the SSL certificate with all the subject alternate name. So it's not the ideal, and therefore that's why it's recommended to use the newer application load balancer ELB, which has SNI server name indication, and if possible, because you are going to be able to use multiple SSL certificates on an application load balancer, and if you want to have a distinct SSL certificate, then from an architecture perspective, you must use multiple classic load balancer. In case like in case you are doing TCP or TCP to TCP traffic, then all the traffic is going to go directly into the EC2 instance. It's going to be translating through the classic load balancer. So this is the only way you can do two-way SSL authentication on a classic load balancer. So the SSL authentication happens at the EC2 level, EC2 instance level. So to summarize here, the client talks to classic load balancer, which talk internally to the EC2 instance. Next we have application load balancer. So it's a layer 7, only HTTP, and you can load balance to cross multiple machines in a target group. Now the load balancing also happen to multiple containers on the same machine, which makes it great fit to be using with the Elastic Container Service ECS, which leverages the dynamic port mapping feature of the application load balancer. It also had support for the HTTP version 2, as well as the WebSocket protocol, and you can have some sort of rules and redirects. For example, could be you can redirect from HTTP to HTTPS directly at the application balancer level. But you can also write your own writing rules, such as path headers, queries, strings, and so on. So we will be here as an example. Here we have an external application load balancer, V2, and two target groups. One of the users that is accessible accessible at the route or user, and the other one for another one for the search, which is available at the root or search. So root // search, and as you can see, each target group will have a different health check. So health check here also the health check have been written. If you are not able to see from my view, I'm just so now. So now, what are the target groups? Now, what are the target groups of an application load balancer and their target groups? And it could be either EC2 instances, and these instances can be managed by an auto scaling group. This is very common pattern. Like it could be Elastic Container Service task managed by Elastic Container Service itself. Again, using HTTP, or it could be Lambda function, in which case your HTTP request is going to be translated for your Lambda function into adjacent events. Then it could be also, it could also be like IP addresses. In this case, if you are, if it's the IP address, then you must register private IP addresses as targets of your application load balancer. Your application load balancer can also route to multiple target groups at a time, and you have health checks, as I said earlier, at the target group level. Next we have version 2 network load balancer. So it's layer 4, and allows you to forward TCP and UDP traffic to your instances, and also to handle millions of requests per second. So it's very high performance. Okay, it has less latency than the ALB, application load balancer, around like 100 millisecond versus 400 millisecond. So 100 millisecond latency with the network load balancer, but 400 millisecond for the ALB. And so you are going to get one static IP per availability zones, and it supports assigning elastic IP as the public IP if your network load balancer is public. So as a use case, a network load balancer are going to be extremely helpful when you need extreme performances, such as for like TCP or UDP traffic, and the network load balancer is not included in the AWS feature, AWS free tier. For target groups, for the NLB, you get EC2 instances, so they get registered directly with the network load balancer, and you are good to go. So it could be IP addresses. So in case you have, for example, some on-premises servers you want to register by, if you wanted to register your EC2 instances with the private IP, you could do this as well. Or finally, a target group of 4 network load balancer could be an application load balancer. Okay, and the use case for this one, this would be to leverage the feature of the application load balancer with, for example, a layer 7 routing. Okay, but you want to keep the static IP features of your network load balancers. So you want to chain them together. It's a very common pattern to actually have here the 4 network load balancer working as a classic application load balancer. So now we have the last kind of load balancer is the gateway load balancer. So the gateway load balancer is used to deploy, scale, and manage a fleet of third-party network control appliances in AWS. So the use case for the gateway load balancer is to do firewall, to do intrusion detection and prevention system, to do deep packet inspection systems or payload manipulations. It operates at the network layers, so layer 3, which operates directly on the IP packets, and it combines the following functions like it's transparent network gateway. That means it's single point of entry and exit for all traffic. Single point of entry and exit for all traffic, and also it's a load balancer because behind the scenes it can deploy and distribute the traffic to your virtual appliances. Okay. So as a technical thing, it uses a ZENEV protocol on port 6081. So as given in the diagram, it will make it super helpful to understand it. So your users wants to access your applications, and here this is the third party, in the bottom written here, third party security virtual appliances. Okay, the target group in the target group. Okay, so here So your users wants to access your application, which is their destination, but you want to scan all the traffic using third-party security virtual appliances. So how do you do that? Okay, well, you deploy a gateway load balancer and you edit your route tables. Now all the traffic is going to go through your gateway load balancer. The target group of the gateway load balancer is going to be these third-party virtual appliances, and they are going to receive all the traffic, analyze it, and if it's good, then we'll keep on sending it back to the gateway load balancer, which is going to forward that traffic back to your application. So here's going to be the added benefit is that the traffic is going to go through your third-party secure virtual appliances. So the target groups for the gateway load balancer could be EC2 instances, or it could be IP addresses, and it must be private IPs. So that's like it for an overview of all the load balancer on AWS. I hope you liked it, and then we will be talking further about the cross-zone balancing. So now let's talk about the cross-zone balancing, load balancing. So let's go through an example of a very imbalanced situation, but it will illustrate the point. There are some of the edges have been missed, here in the availability zone 1 without cross-zone load balancing at the 25, that there would be an edge, and even in the somewhere you can understand that that thing pretty much. Number has been given. So we have two availability zones, and the first one has a load balancer with 2 EC2 instances, and the second one has a so for example and the second one has a load balancer. So a load balancer instance, obviously with 8 instances, we are talking about with cross-zone load balancing and without cross-zone load balancing. In both of the cases, we have in the availability zone 2 instances and the availability zone 8 instances. Okay, so the load balancer instances are part of the same or more general load balancer. So the client is accessing these load balancers. Okay, and so with the cross-zone load balancing, each load balancer instance will distribute evenly across all registered instances in all availability zones. That's what's the cross-zone load balancing. The client itself is sending 50% of the traffic to the first application load balancer instance and the 50% of traffic to the other application load balancer instance. But each application load balancer instance is going to redirect that traffic across all 10 EC2 instances, regardless of which availability zones they are in. This is why it's called the cross-zone load balancing. So if we take a look at the second application load balancer, since it's going to send 10% of the traffic it received, okay, to all these instances, because we have 10 instances, so each of them gets like 10% of the traffic. And same story with the first application load balancer instance with cross-zone load balancing, so each of them gets the 10% of the traffic. And so in this example with cross-zone load balancing, we are distributing the traffic evenly across all EC2 instances, and that may be something you want to have or not as of the requirement, but at least this behavior is available to you, okay, to deploy it. Okay, the second behavior that's available to you is not having the cross-zone load balancing. So we take the same example, but without cross-zone load balancing. The request and the request are distributed in the instance of the node of the Elastic Load Balancer. So in this example, what we have is that the client sends 50% of the traffic to the first AZ and the 50% of traffic to the second AZ. Okay, but the first application ELB instance is going to send the traffic to only the EC2 instances in its region only. Okay, and so that means that each EC2 instance in this availability zone is going to get 25% of the traffic overall, availability zone 1, and okay, so and half and half, okay, 50%, then 25, half and half, and the one on the right hand side will again divide up the traffic So it is so as we can see here, without cross-zone load balancing, the traffic is contained within each availability zone. But if there are imbalanced number of EC2 instances in each availability zone, then some EC2 instances of a specific availability zone will receive more traffic than others. So certainly there's the on the availability zone 1 they are actually receiving 25% of the traffic, and the availability zone 2 they are receiving 6.25% of the traffic from the application load balancer. So they are receiving lesser traffic, and on the availability zone 1 receiving higher traffic. So it's just an option to know that there's no right or wrong answer. It depends on the use cases, and obviously this is the actually the cross zone load balancing. I hope you understand it. Let's move on to some more detail about the cross zone load balancing. So cross zone load balancing for each type of the load balancer. So for the classic load balancer, it's disabled by default, and you have no charges for inter availability zone data if enabled. And for the application load balancer, it's always on. It cannot be disabled, but you have no charges for inter availability zone data as well. For the network load balancer, it's disabled by default. Okay, and you are going to pay charges if you do enable this in the future. And finally, for the gateway load balancer, it's disabled by default also, and you are going to pay charges for inter availability zone data if you enable this feature, cross zone load balancing. Now let's talk about the sticky sessions, also called the session affinity. Okay, so this one that being hidden by me is also an EC2 instance, nothing more. So it's possible to implement what's called stickiness or sticky session, and the idea is that the client doing two requests to the load balancer will have the same instance in the backend to respond to the request. So the idea is that, for example, you have application load balancer with two instances, and you have three clients. Okay, and if the client 1 makes a request and it goes to the first EC2 instance, that means that when it does a second request, that the client 1 does the second request to the load balancer, it will go to the same instance, which is a different behavior, where usually the application load balancer will do a spread of all the requests across all the EC2 instances. Now for the client 2, if it goes to the application load balancer and talks to the second instance, then all the requests will go to the second instance, and the same for the client 3. Okay, so this is a behavior that can be enabled for the classic load balancer and the application load balancer. And how it works, well, there is a cookie session that it's sent as the part of the request from the clients to the load balancer, and has a stickiness, and it has an expiration date in that cookie. That means that when the cookie expires, the clients may be redirected to another EC2 instance. The use case for this is to make sure that the user is connected to the same backend instance in order not to lose his session data, which can take some important information such as login of the user, for example. But if you enabled a stickiness, it may bring imbalance to the load over the backend EC2 instances, in case some instances having the higher traffic. So somewhat I have a very sticky user, so many sticky user is coming to my instance, something like that situation. Now let's have a look at some of the request routing algorithm. So there is one called the list outstanding request, which is at the next instance. To receive the request is the instance that has the lowest number of pending or unfinished request. So basically the instance that is the least currently busy is the instance that will receive the next request. So which makes sense for sure, right? So because you want to make sure that if an instance has less request than other, then maybe has more capacity to receive these requests. So it's available for the application load balancer and the classic load balancer. And so the idea is that the first request will go maybe to the first instance, the second request to go to the second instance, and the third request has to go to to third instance. Okay, because the third instance is right now, so it doesn't have any request. So it has the list outstanding request. So this is how it works, and then the fourth one may go again to the third instance. If the third instance has the list outstanding request, maybe the third request was very quick to finish, and so the fourth one went again to the third instance, and so on. Okay, so now we will be moving on to the next request routing algorithms, that is the round robin. So this is a bit different. Okay, so the round robin is that the targets will have one after the other the next request, regardless of how many outstanding requests are available on your instance. Okay, so this works for the application load balancer and a classic load balancer, and the idea is that the number 1 will go to the number 1 EC2 instance, number 2 will go to the number 2, and the number 3 go to the number 1. Okay, and then number 4 will again go through the same cycle, so number 1 and so on. So this was the round robin request routing algorithms. Moving on to the next request routing algorithm, that is the flow hash. So it is for the network load balancer, and which a target is selected based on the hashing of the protocol, source or destination IP address, source or destination port, and the TCP sequence number. So that means that each TCP or UDP connection is going to be routed for a single target for the life of the connection, which is sort of equivalent for the sticky session on the network load balancer. So very simply, whenever a user makes a request in EC2 instance, all the information I just said below is going to be hashed. Okay, and through a flow hash algorithm that would be hashed, and then thanks to this hash number is going to route the same request from the same user to the same EC2 instance as long as the TCP connection is open. Okay, and this is a specificity for your network load balancer. And so that's it for this lecture. I hope you liked it and you did get some new information, and I will see you in the next one.